Hello everyone, welcome to my YouTube class. In this video we will see how do we count the prime numbers in each row of a two-dimensional array or a matrix. Say for example, if this is a matrix of order 3 cross 5, now we need to count the prime numbers in each row. Now what are the prime numbers over here? The prime numbers over here are 5, 13 and 7, hence the count of the first row is 3. Now the count of the second row, the prime numbers are 2. Now we know that 1 is neither prime nor composite, 4 is not a prime number, negative numbers does not belong to the set of prime numbers, and the next prime number is 17, therefore count is 2. Now coming to the third row, 0 is neither prime nor composite, 5 is a prime number, 11 is a prime number and 19 is a prime number, therefore the count of this row for the prime numbers is 3. Now we know that for a two-dimensional array, if we take the two-dimensional array this way and I declare it, say for example int a of 2 3. Say for example we have declared a two-dimensional array int a of 2 3. What will happen? The memory will be allocated. Now this is 2 rows and 3 columns 0 1 0 1 and 2. And if we assume the starting address or the base address to be 1000, this will be 1004, 1008 and this will be 1012, 1016 and 1020, so on. Now if I write a of 0, what you get? You get the complete row 0. That means the complete row 0 is a one-dimensional array, and this one-dimensional array is represented by the starting address, that the starting address is 1000. Therefore a of 0 will give you 1000, which is the address of one-dimensional array. Now what is that one-dimensional array? It is 0th one-dimensional array. It is 0th one-dimensional array. See here, this is 0th one-dimensional array, this is first one-dimensional array, there would have been second one-dimensional array, hence 2D arrays are called as what? 1D array of 1D arrays. It is an 1D array, collection of so many 1D arrays forms a 2D arrays. Now similarly, if I write a of 1, what will happen? It will give us the complete row a of 1. That means it will give the one-dimensional array. This is one-dimensional array. If you see clearly, this is a one-dimensional array, and this is represented by the starting address or the base address of a of 1, and this happens to be 1012, and this is address of 1D array. And which is the 1D array? It is the first one-dimensional array. It is the first one-dimensional array. It is the 0th array. This is the first array. Now why this is important for us? Now in this case of matrix, what we will do, we will take each row of a matrix. Each row of the matrix is a one-dimensional array, and we already know how do we count the prime numbers in one-dimensional array. Therefore what we write over here, we say for the value of I starts from 0 because it is the 0th row. And how many number of rows are there? In general, let me take, there are R number of rows, and we say I plus plus. And what we can do over here, we can call one function called as count primes. We call one function called as count primes. And what I can write? I can write a of I. I can write a of I. Now the value of I is 0, a of 0. Assume that the base address is 1000 over here. Okay, let me write it. Assume that the base address is 1000. Now what will happen? 1000 will be passed, and this is a one-dimensional array. And this is a one-dimensional array. I plus plus I is 1, 4, 8, 12, 16. This will be 20. 1020 will be passed. I plus plus 2, 1040 will be passed. And whenever we say count the number of prime numbers in the one-dimensional array, there are 3 prime numbers, 2 prime numbers, 3 prime numbers, 0 prime numbers, 100 prime numbers. Therefore it can give us the answer, and let us store it in some variable, and you print the value of y. This becomes how do we count the number of the prime numbers in each row of a two-dimensional matrix. It is very simple. See, a two-dimensional array is a collection of 1D array of 1D arrays. Therefore each row is a 1D array, and I can pass each row this way. A of I means the starting address will be passed, and it will give you how many number of prime numbers are there, so that you can print it. Please pause the video right over here and try to write the program yourself, and then we will see how do we write the program and the tracing of the program. Thank you. Now let us see how do we write the code for the same. Now the first thing that we write is, we say hash include stdio.h. Now next we need some functions that we will see it. I directly start with the main. The input for this program is a two-dimensional matrix, a two-dimensional array. We say int a of, we write here number of rows and number of columns. Now what is this row and what is this column? We need to define it. Therefore we write here hash define. Let the number of rows be say 10, you can make it as 100, anything. And I write here hash define number of columns to be 10. Now what will happen as soon as you say this? The memory will be allocated. And where does the memory is allocated? Memory is allocated in the main scope. Suppose this is the main scope. Now the memory is allocated. A two-dimensional array will be created of 10 rows and 10 columns. Now let me draw this one. This is the 0th column, first column, second column, third column, and so on up to 9th column, and so on up to 9th column. Now this is the 0th row, first row, second row, and so on up to the 9th row, so on up to the 9th row. And the array name over here we have taken here is A. It is represented by base address. Let the base address of this be say 1000, 1004, 8, 12, so on up to 1036. And what will be this address? It will be 1040. You calculate this, this address will be 1080. These are the addresses. Whatever I have written with the blue pen, these are the addresses. Now after you create this, is it necessary for us to store all 10 rows and 10 columns? No. We may store R number of rows and C number of columns. Therefore, let us take here int R and C, which represents how many number of rows we want to store and how many number of columns we want to store. And then we read the order of matrix. We say printf enter order of matrix, enter order of matrix. And how do we read the order of matrix? We say scanf %d, ampersand R and ampersand C. Now we have two more variables in the main scope, R and C. Let the value of R be say 3 and let the value of C be say 4. That means we want to store 3 rows and the 4 columns. Now we have to read the matrix, and for this already we have written a function called as read matrix. We call that function read matrix. Which matrix we want to read it? A, how many number of rows are there? R number of rows. And how many number of columns are there? There are C number of columns. You may display the matrix as well. Let's call the function display matrix. Which matrix we want to display? A, how many number of rows are there? R. And how many number of columns are there? C number of columns. These two functions are not inbuilt. We need to write it. Please write these functions read matrix and display matrix yourself. Now the main task is to count the number of prime numbers in each row. Now as soon as you read the matrix, let me give some values over here. Let's say 5, 3, 8, 4. Okay, now you have to read the matrix over here. Let me say 0, 3, 2, 9. And you have to read the matrix over here as well. I say 1, -7, 11 and 13. Let this be the matrix, and we need to count the prime numbers in each row. Now how many prime numbers are there in first row? There are 2 prime numbers. Second row, how many prime numbers are there? There is only one prime number, that there are 2 prime numbers, 2 and 3. How many prime numbers are there in the third row? Again there are 2 prime numbers, 11 and 13. That means there are multiple values and a function can return only one value. Therefore we take the return type of the function as void. I say void, and let me write one function called as, I say count primes. I say one function called as count primes. And in which matrix I want to count prime? In the matrix A. Therefore it is of type integer 2-dimensional array, and I say this is the 2-dimensional array. You cannot skip the column size, but you may skip the row size. How many number of rows are there? R number of rows. And how many number of columns are there? There are C number of columns. Therefore I call the function here count primes. What is the first parameter? integer two-dimensional array A, R number of rows are there are C number of columns, return type is void because there are more than one possible answers and a function can return only one answer. But still, if you want to return the answer, you can put it in an array or you can put it in a list and can return the answer Then we say return 0 and this completes the main function. Now next, let us see how do we implement this function count primes. Now what is the prototype? We say void. What is the function name? The function name is count primes. What is the first parameter? Integer two-dimensional array. What is the second parameter? The second parameter is the number of rows, that is R, and the third parameter is the number of columns C. Now what happens as soon as you call the function? The scope of the function get activated. Now this is count primes function. And how many parameters are there? There are 3 parameters. What are the 3 parameters? The first parameter is A, second is R, and third is C. We know that whenever 2D arrays are passed to the functions, the base address gets passed, not the complete array. And what is the base address here? The base address happens to be 1000. The number of rows is 3 and the number of columns is 4. Now what we want to do? We want to count the number of primes in each row. That means you have to take the first row and check how many primes are there. Take the second row, check how many primes are there. Take the third row, check how many primes are there. Hence, what I can do, I have to take each individual row. And how do I take each individual row? We say for the value of I is 0 because row number starts from 0. How many number of rows are there? There are 3 number of rows. Therefore, I less than R, and we say I plus plus, Now, if I say A of I, that means A of 0, 1000 will get. I plus plus 1, A of 1, 1040 will get. I plus plus 2, A of 2, 1080 will get. Are you getting it? That means A of I is a complete one-dimensional array. Hence, I can write it over here, a function called as, you can say anything. Let me say prime count in 1D array. You can give any function name. I have given prime count in 1D array. Now, which 1D array? In 1D array A of I. And if I say A of I, 1000 will be passed. Now say me how many elements are there in this one-dimensional array. This is the one-dimensional array. Okay. Now in this one-dimensional array, how many numbers are there? 1, 2, 3, 4 numbers are there. Now why there are 4 numbers? Because the number of columns are 4. Hence, the second parameter is how many numbers are there? There are column number of numbers are there. How many columns are there? So many numbers are there. And we will see the return type in some time. I need to write the function prime count in one-dimensional array. Now, what is this A of I? A of I means one-dimensional array. Again, I am saying A of I is not two-dimensional array. A is a two-dimensional array, but A of I is a one-dimensional array. Therefore, I need an one-dimensional array. Let us write this as the one-dimensional array. And we know that in one-dimensional array, giving the size is optional. And what is this C? C is of type integer, which represents the number of elements. We will see the return type. Now what happens as soon as you call the function? The scope of the function gets activated. Now this is the scope of the function. What is the function name? Prime count in 1D arrays. Prime count in one-dimensional array. Is that okay? Now how many parameters are there? There are 2 parameters. What are the 2 parameters? The first parameter is B, which is an one-dimensional array, and the second parameter is n, which represents the number of elements. Now A of I is copied to B. Now what is the value of I in count primes? The value of I in count primes is 0. Now A of 0, what is A of 0? It is 1000. 1000 will be copied to B. Therefore this is 1000, which is an one-dimensional array. Again I am saying it. C will be copied to n. Now what is the value of C? It is 4. That means at address 4 there are 4 number of array elements. Please access those and check if those numbers are prime or not prime. Now I need to access each element of a matrix, each element of a one dimensional array, and we know that how to access it. We say int I for I is equal to 0, I is less than n, I plus plus, right? And what do I have to check? Now if I say b of 0, now say me what is b of 0? What is b of I? I am working here is equal to star b plus I. This is the pointer notation, and this compiler internally converts to what? Star b plus I into d. This compiler internally converts to star b plus I into d. Now I say I is 0, I is less than n. Now I will write one function called as is prime. Already we have written a function called as is prime, and assume that there is one function called as is prime which will give answer as 1 if the number is prime, and it will give answer as 0 if the number is not prime. Is prime, and which number I have to check if it is prime or not? I need to check b of I is prime or not. Now the value of I is 0. Replace 0 over here. Now what is b of 0? B of 0 is nothing but star b plus 0. The compiler does the scaling factor or the pointer arithmetic. It becomes star b plus 0 into d. Now what is the value of b in the function count prime? It is 1000. Therefore it is star 1000 plus 0 into d. D is nothing but size of array data type. It is 4, and it becomes star 1000. It becomes what? Star 1000. Now what is star 1000? This is the rough work. What is star 1000? Star 1000 means go to address 1000 and fetch the value which is 5. Now b of I will give you 5. Is prime function will be called, and it will say if the number is prime number or not a prime number. Now before I say how do we write is prime function, please pause the video over here and copy down this main function, and you have to write the appropriate prototypes for read matrix, display matrix, count primes. Already I have written it. The next thing is count, prime count in 1D array whose return type will be an integer. You have to write it yourself, and the another function that prototype you have to write is the is prime. Please pause the video over here. I am going to erase this, and we are going to write the is prime function over here. Thank you. Please pause the video and make the notes. Let us see how do we write the is prime function. Already we have written it. It returns 0 if the number is not prime, 1 if the number is prime. Therefore the return type is int. The function name is prime. What is the first parameter? B of I. And what is b of I? It is star 1000. And what is star 1000? 5. And 5 is a integer. Therefore it takes integer as the input. And we know that a number is prime if there is no factor less than or equal to square root of the given number. Hence you have to say math.h as well. I say int I, we say for I is equal to 2, I is less than or equal to square root of n, and then I say I plus plus. What do we write here? If n is divisible by I, then it cannot be a prime number, and if it is not a prime number, we will return 0, and if it is a prime number, we will return 1, and if it is a prime number, we will return 1. This already we know it. Now which function we are calling? We are calling the is prime function. Now as soon as you call the function, what happens? The scope of the function gets activated. Please see here, this is prime function. This is prime function. How many parameters are there? There is one parameter n. Now what will happen? B of I will be copied to n. Now what is B of I? Star 1000. It is 5. Already I worked it. 5 is copied to n. Now the value of I starts from 2. Square root of 5 is also 2. 2 less than or equal to 2. Yes. 5 modulo 2 equal to 0. No. I plus plus. The value of I becomes 3. 3 less than or equal to 2 is false. You come out of this loop and you say return 1. As soon as you return, the scope gets deactivated and 1 will be returned to the point from wherever it is being called, and it is our responsibility to store it in some variable, and let me store it in some variable p. Now I check if the value of p is 1. Yes sir, the value of p is 1. it means that the number is prime. And if the number is prime, what I have to do? I have to count each prime number. Therefore, what should be the initial value of count? The initial value of count is 0. And what do I write here? I say count plus plus, because I need to count it. I say count plus plus, hence the value of count will become 1. Hence the value of count will become 1. Is that okay? Now, again you say I plus plus, we are in the prime this scope, the value of I will become 1. Sorry, count will become 1 here. Count will become 1. Here there is no count. And I say I plus plus, the value of I will become 1, because we are in the prime count function. Now, 1 less than n. What is the value of n over here? The value of n is 4. 1 less than 4, yes. B of 1. Now, what is B of 1? Star B plus 1 is nothing but 1000 plus 1 into 4 is nothing but 1004. And what is star 1004? It is 3. Again, you call the function is prime of 3. As soon as you call the function, the scope of the function gets activated. Now, this is prime. There is one parameter, that is n. Now, B of 1 will be copied here. That means 3 is copied here. And we know that 3 is prime, therefore it will return 1, the value of p will be 1. Again you say count plus plus, the value of count becomes 2, saying that there are 2 prime numbers. Again you say I plus plus, the value of I becomes 2, 2 less than 4, yes sir, 2 is less than 4, b of 2. Now what is b of 2? Calculate here, it is b plus 2 is nothing but 1000 plus 2 into 4 is nothing but 1008. This is 1000, 1004, 1008. Which is 8. Now 8 is copied to, now there is one function called as is prime, 8 is copied here, we know that 8 is not prime, therefore it returns 0, the value of p will be 0, 0 equal 1 is false, it doesn't do count plus plus, therefore the value of count is still 2. Now again you say I plus plus, the value of I will become 3, 3 less than 4, yes, b of 3. Now what is b of 3? B of 3 is equal to star b plus 3 is equal to 1000 plus 3 into 4 is nothing but 1012. 1000, 1004, 1008, 1012, it is 4. 4 is copied to n. Now again we know that 4 is not a prime number, it will return 0, the value of p will be 0, 0 equal 1 is false, it doesn't do count plus plus, again it says I plus plus, the value of I will become 4. Now see here, 4 less than 4 is false, because 4 less than 4 is false. You come out of this loop, and where is the count of prime numbers is stored? It is stored in count, hence I say return count. Hence I say return count. Now what is the value of count? The value of count is 2. It will return 2. As soon as it returns, the scope of this function gets deactivated. You may pause video here and you may write the scope diagrams. It will return 2. Now it is my responsibility to store the answer in some variable here. Let me store it in some variable called as c. And what do I write it here? I say printf %d /n comma c, where 2 will be printed. You may pause video here and do the all rough works, whatever you need. Okay, now after it prints 2, again it says I plus plus. Now the value of I will become 1 in count primes. 1 less than r. What is the value of r? 3. 1 less than 3. Yes, now we are counting prime for the second row. I will do for second row, third row you do yourself. Again you call the function prime count of 1D array. Now as soon as you call the function, what will happen? The scope of the function gets activated. Now this is the scope of the function that got activated. How many parameters are there? Again there are 2 parameters. The first one is b and the second one is n. Now what will happen? A of 1 is this complete row. It is an one-dimensional array represented by 1040 is copied to B. Therefore, 1040 is copied here. Next, C. That means there are column number of elements. C is copied to n. The value of C is 4. 4 is copied here. Again, the value of count is 0. I write here because I need to start counting from 0 again. I is 0. 0 less than n. The value of n is 4. Please see there. Yes, is prime of b of I. Now say me, what is b of I is equal to? It is star b plus I, and the compiler internally converts to what? Star b plus I into d. Now I need to count b of 0. What is b of 0 is equal to star. Now say me, what is the value of b? The value of b is 1040 plus 0. Compiler converts scaling factor 1040 plus 0 into 4, and this becomes star 1040. Now what is star 1040? Go to address 1040 and fetch the value 0. Now you are calling the function is a prime of 0. Now say me, is 0 a prime number? No. Therefore what I need to write here, I say if b of I is less than or equal to 1, then we write here continue. Now b of 0 is star 1040 is 0, 0 less than or equal to 1, yes, you simply continue and you say I plus plus, the value of I becomes 1. Now 1 less than 4, yes, what is b of 1 is equal to star 1040 plus 1, compiler converts to 1040 plus 1 into 4 is 1044. Now what is 1044? It is 3. Now again 3 less than or equal to 1, no, you call the function 3 for the prime number, the scope of the is prime gets activated. Now 3 is a prime number, we know that it will return 1, the value of p is 1, 1 equal 1, yes, again you say count plus plus, the value of count will become 1. Now you say I plus plus, the value of I becomes 2, 2 less than 4, yes. Now what is b of 2? B of 2 is equal 1040 plus 2 is equal 1040 plus 2 into 4 is equal 1048. Now this is 1040, 44, 48. Now star 1048 is 2. Now 2 less than or equal to 1, no. Again you call the function is prime of 2. Yes sir, it is a prime number, needless to say. Therefore the value of p will be 1. 1 equal 1, yes. Again you say count plus plus, the value of count will be 2. Done. You say now I plus plus, I will become 3. 3 less than 4, yes, b of 3. Now what is b of 3? Is equal 1040 plus 3 is equal 1040 plus 3 into 4 is nothing but 1052. It is 40, 48, 44, 48, 52. 52 is 9, 9 less than or equal to 1, no. You again call the function is prime of 9, the scope gets activated, it is not a prime number, it returns 0, the value of p is 0, 0 equal 1 is false, do not count it. Again you say I plus plus, the value of I becomes 4, 4 less than 4 is false, you come out and you say return count. As soon as you return, the scope gets deactivated, the value of count is 2, it will be stored in C, again it prints 2, saying that there are 2 prime numbers in this case. Again you say I plus plus, the value of I becomes 2, 2 less than 3, yes, 2 is less than 3. Now again you call the function prime count 1D array. Now this is prime count 1D array for the third attempt. How many parameters are there? There are 2 parameters, one is b, the other one is n. Now this is b, this is n. Now what will happen? A of 2 will be copied to b. Now what is a of 2? It is 1080, it is an one-dimensional array. Now c is copied to n, which is 4. B of 0 is nothing but 1080 plus 0. Are you getting it? B of 0 is nothing but 1080 plus 0 is nothing but 1080 plus 0 into 4 is nothing but 1080. Now what is 1081? You count it. I plus plus 1. B of 1 is nothing but 1080 plus 1 is 1080 plus 1 into 4 is 1084. You check 1084 is prime or not. 1088, 1092 and I plus plus 4. 4 less than 4 is false. Whatever is the count, you return there, you print. As soon as you release, the scope gets deactivated. I plus plus, the value of I becomes 3. 3 less than 3, the condition is false. You come out, closing bracket of the function is again taken as return. The scope dies. You come back to main and you see that the prime numbers are printed of each row. Very, very simple program. Please pause the videos at the appropriate positions and make a clear note. Write all the prototypes. What are the prototypes you need to write? Read matrix, display matrix, count primes prototype. Already I might have written this prototype int prime count 1D array of int, one dimensional array integer and the is prime function. Very important question and very simple question as well. Thank you. Thank you friends for watching this video. Please like to my channel, subscribe to my channel and share the channel with your friends. Thank you.